Okay, so we're going to go ahead and solve another problem involving two-dimensional circular motion. So let's go ahead and draw it out. So we're playing tetherball. So imagine, like, here's our ball of mass. Oh, they give us the mass, 0.42 kilograms. And the ball is 1.2 meters from our tetherball pole, which is, let's go ahead and draw that going down. The speed, the velocity is what, 5.7 meters per second. And it's traveling in a circular horizontal path. So let's just imagine it's traveling like that. Let's say, the tetherball length of the rope is not getting, shorter or longer. It's just kind of there. Cool. So we're going to find a couple things. Okay, we want to find the angle it makes, tension, and length of the string. Awesome. So many fun things. So after we draw our picture, first step always for circular motion force problems is draw your free body diagram. So let's see, what do we have on this? We have force of gravity going down, which we know that'll be 4.2 newtons, and we have tension at an angle. Cool. So now let's go ahead and do our coordinate system. So we'll say up and down is the y direction, and x direction is horizontally. So it's moving in a circle in the x direction. So that's going to be our F net c direction. So let's go ahead and see. Any forces we need to split into x and y? Tension. Let's go ahead and split that into our x direction and our y direction. So we have tx and ty. I'm going to go ahead and just redraw the free body diagram with the forces we're going to put into our F net equations on the side. So essentially we'll have tension y, tension F, and Fg, which we know is 4.2 newtons. Okay, so again, if we were to draw a graded free body diagram, again, just draw what's ever in red, which I just highlighted in yellow. Don't draw the components on a graded one. But for solving, components are so important. Okay, so we drew our free body diagram that we'll use for our thinking purposes. Now let's go ahead and set up F net in the x direction and in the y direction. So we have x and we have y direction. Okay, so x direction is moving in a circle in the x direction. So let's call that F net c. Y direction, it's not moving in a circle in the y, so let's just call that F net. So in the x direction, we have F net c is equal to tension in the x direction. Okay, so we have Tx. F net is MAC, and AC is what? M times B squared over R. Cool, equals what? Tx. Let's see what numbers we can plug in. Mass is 0.42. Velocity, oh my goodness, they give us the velocity, that's fun. 5.7 squared over the radius. Oh, they give us that too, that's great. Equals 1.2 equals Tx. So we just got a number for Tx, which I got 11.37 newtons for Tx when I typed that in my calculator. Cool, so that's going to be important. Now let's go ahead and look at F net y. So we have, that's going to be tension y minus Fg. Tension y we don't know. Fg is going to be 4.2. F net is always MA. Keep in mind we don't put AC here because it's not moving in a circle in the y direction. It's only moving a circle in the x direction. So M is 0.42. What's it doing in the y direction even? It's not moving in the y direction, so that's just going to be 0 equals Ty minus 4.2. So Ty, I just get to be 4.2 newtons. Cool. So now let's go ahead and set this up. So we have, for A, we want to find the tension force. So we just found that the X tension was 4.2. We just found the Y, sorry, I mixed that up. The X tension was 11.37. Sorry, that was not proportional. And the Y tension was 4.2. I'll make it a little more proportional. We want to find the total tension T, which is again what I had in red and then highlighted in yellow over here. Let's think about how we want to find that. Those are perpendicular. I bet you all have clever ideas. Beautiful. Let's go ahead and do the Pythagorean Theorem. So T squared equals 4.2 squared plus 11.37 squared. I go ahead and do some fun math, and I get T to be 12.12 newtons. Awesome, got T. So now let's go ahead and see if we can find the angle theta. So I want you to first think about how you find that angle and then check back in the video. Okay, so if I want to find that angle, I'm going to go ahead and use my good old SOHCAHTOA. So let's see, I know I'm going to use tangent because I know 11.37, 4.2. And again, if I want to find the angle, I'm going to do the inverse tangent. And I'm going to find that angle in degrees, so make sure your calculator's in degrees. So inverse tangent of what? 11.37 over 4.2 equals theta, which that turns out to be 69.7 degrees. Cool. So we also found the angle. Awesome. So just one last little part to the problem. For C, we want to find the length of the string. So we want to find, we'll go ahead and highlight in different colors. We want to find that whole entire length. Pause the video, think about how you might find that length, and then check back in. Okay, so if I draw it out, keep in mind forces are equal to forces and lengths are equal to lengths. So if I draw this out, so I have what? This radius is 1.2 meters. This angle is 69.7 degrees. Keep in mind, like the lengths are proportional to that like angle, and like, you know, the forces are proportional to that angle. Okay, and again, this is our length right here that we want to find. So I look at this. This looks like a good old SOHCAHTOA problem. Sometimes, again, I just write out my SOHCAHTOA so I remember which one I'm going to use. So in this case, we have opposite that angle is opposite, and we also have hypotenuse, so that's going to be sine. So if I set this up, sine of 69.7 degrees equals opposite 1.2 over length. So I go ahead and do some fun math. So length equals 1.2 over sine of 69.7 degrees. Again, make sure your calculator's in degrees. And I get the length to be 1.28 meters. Cool. And let's see, does that make sense? Yeah, that's the hypotenuse, so it should be longer than the radius. So cool. Awesome. Thanks for watching.